Determining the Laplace transform of different waveforms using waveform synthesis. In that, so this is a one example. So now we'll determine the Laplace transform of this waveform. When we clearly observing this waveform, this y-axis is its magnitude and x-axis is the time in units. And 0, 1, 2, 3, 4, and 1 to 2, this waveform exists. And 0 to 1, and after 2, it's a 0. And at point 1, its magnitude is -1. And at 1 to 2, it is a ramp function. It is a ramp function with the slope that is y2 minus y1, that is -2 minus of -1, that is divided by x2 minus x1, it is a -1. So this we have to determine the Laplace transform using waveform synthesis. We will take this one, start writing the waveforms. This is a step function, unit step function. Its magnitude is -1. It's a -1. And where it is started? It is started at 1. It is a delayed by a 1 unit time. And that's why its magnitude is -1. That is minus of u t minus 1. At the same point, means at the same time, again a ramp function is started with the slope of -1. That's why I'm going to start another ramp function at a time unit 1 with the slope of -1, that is a -1 into r of t minus 1. This -1 because it is started at a unit time 1. When we add these two waveforms, the summation of that we will get like this. But this will be go on increasing. But at 2 unit time 2, it has to come to 0. So now it is go on increasing. I have to stop at the unit time 2. Yeah. So this one in the previous what we got, I have to stop at 2 unit time 2. That's why I'm generating, this is a negative going one. I'm generating a positive going ramp function, and that will be started at a 2 unit time, r of t minus 2. It's again slope is 1. When I'm adding these two, when it is reached 2, so this is a 2, it's a 0. Now I'm getting a, after 2, it will be constant with a magnitude 2. But it should come to 0 at point 2. It should come to 0 at time 2. It should come to 0. To do that, I'm going to add a unit step function at unit time 2 with a magnitude of 2, because this will be of a -2, and this is a 2u of t minus 2. When I'm adding these two, this will be get cancelled. At 2, it's a 0. So next onwards, 2 onwards, it's a 0. Yeah. In this way, we can use a waveform synthesis to get a Laplace transform. Totally, there are 4 functions. F1 of t, it is a -u of t minus 1. F2 of t minus r of t minus 1. And F3 of t, r of t minus 2. F4 of t, 2u of t minus 1. Minus u of t minus 1, r of t minus 1, r of t minus 2, 2u of t minus 2. Unit step function 1 by s e to the power of minus s. It is a minus because this one is minus. And negative going ramp functions minus its Laplace transform of t is a 1 by s square, that is e to the power of -1, because it is delayed by a minus s. Again, this is a ramp function 1 by s square e to the power of -2s, and this is a unit step function 2 by s e to the power of -2s.